Today we are going to begin section 7.4. We're going to look at increasing and decreasing and how that relates to the derivative. So two things we're going to talk about today. The first is definitions, and then the second is the relationship between the derivative itself and the behavior of the graph. We'll spend a lot more time with this tomorrow. Okay, so first of all, looking at some definitions. When given the equation of a function, we're going to be looking for the intervals where the function is increasing and where it is decreasing. So it would be helpful if we had a definition for those two words. So the first one there is increasing, and this says an increase in x produces an increase in y, which basically means as you move from left to right, you are also moving in an upwards direction. So that could be something like this. All right, and as I go from left to right, you can see that I'm continuously going up. We would call that strictly increasing. Or it could be something like this, where it levels off and then keeps going up. This function is also called increasing because at no point does it go down. It's always moving upwards or flat. Decreasing is exactly the opposite. Decreasing says an increase in x produces a decrease in y, which basically says as you move from left to right, you are also moving in a downward direction. So I could have something like this. Again, this would be called strictly decreasing because at no point does it level off. Or you could have something like this where it decreases and levels off and decreases and levels off. And this one is considered decreasing as well because at no point does it increase. Okay, so pause the video for a second, write those two definitions down, draw the pictures so that you have that to move forward. Okay, now that we have our definitions, let's look at some intervals. So in IB, they want you to do these intervals as set notation, which is similar to what you did in Algebra 2. For those of you guys moving forward to pre-calculus and calculus, you're going to have to get used to interval notation. If we have time, we'll go back and talk about that some more. But for right now, just for the length of the video, we're going to focus on set notation. So the first one here says increasing. Increasing basically meaning going up. And you can see that as I go from left to right, always read graphs from left to right, just like you read a book. I'm increasing right here, and I'm also increasing right here. So I'm going to have two different places for my increasing intervals. 1, 2. So that first one, always base your intervals only on your x values. All right, so we're not even going to consider the y values right now. We're just going to ignore those. This one is increasing when x is less than -1, right? I can see that in this area it is going up, and it is also increasing right here when x is greater than +1. Notice that this does not say greater than or equal to, because actually at -1 and +1, the graph is neither increasing nor decreasing. It's kind of stationary for a minute. All right, the function is decreasing right here. As I move from left to right, my y values are going down. So that would mean it's decreasing from -1 up through +1. So this notation means that my x values where it's decreasing are in between -1 and 1. And again, I don't have any equal to there because actually at -1 and 1, it is neither increasing nor decreasing. It just pauses for a moment. Okay, if you have those graphs that I texted you guys about yesterday, if you will get those out so that you can do this activity, this will make a lot more sense if you have those graphs and you do it with me. So the first thing I want you to do, pause the video, and for each of the curves that you have, I want you to go through and put a dot on the maximums and minimums and label them as max or min. Okay, so take a second to do that. Okay, this is what your paper should look like at this point. So I have all of my maxes and mins labeled. Check yours, make sure it matches mine, pause the video, change anything that you need to. Okay, our next direction is going to be to draw little short tangent lines at each of the maximum and minimum values that you found. Okay, so pause the video again, draw little short tangent lines at each of those maximums and minimums. Okay, this is what yours should look like. You can tell that at each of those maximums and minimums, if it's going to be tangent, if it's only going to touch the graph at one point, then those little tangent lines are going to be horizontal. Well, if you remember from what you've done in the past, the gradient of every horizontal line is 0. So that tells me that the gradient of the tangent line at every one of those little values is equal to 0. Well, what finds for us the gradient of the tangent line? Well, that's the derivative. So that means that the derivative is equal to 0 at every value x where I have a maximum or a minimum. That's going to be a really important point for what we're going to do moving forward over these next few days. Okay, pause the video again. I want you to draw a few tangent lines on the left side of the minimum values and then make some observations about their gradients. So pause the video, look at your minimum values, draw a couple of tangents on the left-hand side of each, and then make some observations. Okay, so here's mine. And if you look, you'll notice that my little tangents are all moving in a downward direction. The gradient of each of my tangents on the left-hand side of the minimum is going to be negative because my little lines are moving in a downward fashion. All my little tangents are going down. Okay, if you didn't get that, fix yours so that it looks like mine. Okay, now I want you to do the same thing for the right-hand side of the minimum values, kind of ignoring the maximums right now, focusing on the minimums. Draw some little tangent lines on the right-hand side of all those minimums. Pause the video and then make some observations. Okay, so here we are, and I changed the color to make it a little bit more obvious which ones are which ones. You can see the blue ones here that I've made on the right-hand side of the minimums. And if you look at the gradients of those, you'll notice all the gradients are positive. All of those are moving upwards. All of those are increasing. So therefore, their gradients are positive. Okay, one last thing. I want you to basically do the same thing for the maximums that we just did for the minimums. Look at the left-hand side, look at the right-hand side, make some observations about the little tangent lines that you can draw on both of those. Pause the video. Okay, so this is what you should have at this point, and we see that on the right-hand side of the maximums, the gradients are going down, they're negative. On the left-hand side of the maximums, the gradients are going up, or the little tangent lines are moving up, so their gradients are positive. The little tangent lines are moving down, their gradients are negative. Same thing here, I'm going to have some positive gradients on this side, negative gradients on that side. Positive gradients on this side, negative gradients on that side. So we see that actually at the maximum minimum, the derivative is equal to 0. On the left-hand side of the minimum, the derivative is negative. On the right-hand side of the minimum, the derivative is positive. On the left-hand side of the maximum, the derivative is negative. And on the right-hand side of the maximum, the derivative, oh, I said that backwards. On the left-hand side of the maximum, the derivative is positive. And on the right-hand side of the derivative, the right-hand side of the maximum, the derivative is negative. Sorry, I got that sentence all mixed up. Okay, so let's fill in some blanks here. Take a second, copy these sentences down, and then we'll fill in the blanks together. So take just a second and copy those down. Okay, so what happened at the maximum? Okay, we'll go back and look. At the maximum right here, the gradients were positive, and then the gradients were negative. Okay, so let's write those down. The gradient changed from positive, oh, that did not work out like I hoped it would, to negative, where the graph has a maximum value, right? At my maximum, it changed from positive to negative. Okay, so what happened at the minimum values? Okay, let's go back and look. Here's a minimum. You see my gradients here have negative values, and my gradients here have positive values. So it's exactly the opposite. The value of the gradient changes from negative to positive, where the graph has a minimum value. And so fill those blanks in. The behavior of the graph when the gradient is positive. Okay, so what is the graph itself doing when the gradient is positive you can see all these places where the gradient is positive, we can see that the graph itself is increasing. Move that up on the screen there. And when it's negative, okay, let's go back and look. So here my gradients are negative, here my gradients are negative, here my gradients are negative. In all of those instances, the graph itself is decreasing. Okay, so that makes sense. If I have a maximum value, then the graph should be increasing followed by decreasing. If I have a minimum value, then the graph should be decreasing followed by increasing. Let's look at what that looks like. All right, so if I have this value right here, and I want that value to be a minimum value. All right, if that's a minimum, then that means my graph should go down. Oops, I missed it. Go down and then up. So my gradient here will be negative. My gradient here will be positive. All right, let's draw another one. Okay, I'm going to put one over here. All right, let's suppose we want that value to be a maximum. If that's going to be a maximum, it's going to be at the top of the hill. So the gradient here is positive, the gradient here is negative, exactly the opposite of what we had there. Okay, last thing we need to do for today, and these are our official definitions of increasing and decreasing. So a function f of x is increasing on an interval s, whatever that interval happens to be, if the derivative is greater than or equal to 0 for all x in that interval s. So the greater than 0 part is where it's actually going up. The equal to 0 part is where it's leveling off, and it's a horizontal segment in that case. But in both of those, that's considered increasing because at no point is it going down. All right, a little bit more restrictive than that. Look right here. Do you see that that's only greater than? There's no greater than or equal to. Well, if it's only greater than, it must only be going up. It's never going to level off. So we would call that strictly increasing. So that's the difference between those two. For increasing, I can level off and become horizontal, but for strictly increasing, I cannot. Okay, pause the video. Make sure you get those two definitions written down. Okay, last two definitions. The function is decreasing on this interval if the derivative is less than or equal to 0. So again, less than is going to be where it's actually going down. Equal to is going to be where it levels off and goes horizontal. But that's still considered decreasing because at no point does it change and go up. And then the last one, the function is strictly decreasing. Again, you can see, just like before, we dropped the equal to right here. So it's only less than. It's only going down. At no point does it level off and go horizontal. Okay, so pause the video again. Make sure you've got those last two definitions written down. Okay, at this point, we have completed the information you need for worksheet 7.4, question number 1. All right, so go back to question number 1, see if you can write those intervals, and your intervals are actually going to be sets. They're going to look like this. IB is going to call those intervals. That's not actually what an interval looks like. For those of you guys who are going to take pre-calculus or calculus next year, I'll just show you this one. This interval right here, you can see it would normally have an arrow on the end right here. It is going on and on forever, going down. So that interval would be from negative infinity up through the x value of -1. So this set, x is less than or equal, or just less than, sorry, x is less than -1, is the same thing as this interval, negative infinity to -1. IB is asking for sets. Pre-calculus and calculus will ask for intervals.